Calculating and understanding how to interpret our value for skewness is going to be important throughout this course. It's going to be a number that we fall back on in a lot of different scenarios to understand what measures are best for answering the questions that we're trying to tackle. What we want to talk about next then is choosing the best measure of center and look at how skewness ties into that. The mode, which we talked about, is generally most useful for qualitative data sets. We can't calculate the mean of your favorite state park or the median of your favorite shoe brand, but we can identify the mode if it exists. So we talk more about the mean and the median when we talk about quantitative data, and the mean is considered to be the best measure of center for quantitative data. And I put best in parentheses because that's not exactly an incredibly accurate statement, but it's sort of a good shorthand way to think of the mean. So if we refer back to the formula for calculating the mean, x bar, we take every single data value in that data set, add all of those together, and then we divide by exactly how many data values are in that data set. So divide by 30 if we have a data set of 30, divide by 15 if we have a data set of 15. The really good thing about this formula is that every single data value is taken into account. Or every single data value is considered as a part of that calculation. The problem with the mean is that it's very sensitive to outliers. And skewed data. If we have skewed data or if we have outliers, the mean can be artificially increased or decreased by those few extreme values. So the median can be thought of as the backup, which again we're putting in a set of quotation marks there because this isn't incredibly technical language. But the mean can be thought of as the best measure, and the median can be thought as the backup measure of center for quantitative data. The drawback of the median is that it's based on, at most, 2 data values. Sometimes only 1. So we're not taking all of the data into account really when we calculate the median, but it is highly resistant to outliers and skewed data. So if we have one or a few values on the high end or low end that don't fit with the rest of the data, the median's not going to be dramatically changed. In example 6 then, we want to look at a couple of cases where we choose the appropriate measure of center based off the information that we have available. In example 6, we're told that in a recent study, researchers found their data had a skewness of 0.8207. In part A, it says this value for skewness suggests that the data is, in this case that's between -1 and 1, so our data is approximately symmetric. Since our data is approximately symmetric, our best choice for the measure of center would be the mean. It takes all the data values into account, and since our data is not skewed, we don't have a lot of outliers present, which would indicate skewness in our data, the mean is a very good measure of center. But in example 7, in another data set, the skewness ended up as -1.3327. So that's less than or equal to -1. So that suggests our data is highly left skewed. So if our data is highly left skewed, there may be outliers. The mean could be artificially inflated or decreased. So we would turn to the median as that alternative measure of center because it's resistant to skewness and outliers. It's not going to be dramatically affected by a few values at the high or low end that don't fit the rest of the pattern.